Welcome to another episode of Python for LEGO Robotics. Today we're going to learn how to code Blast to guard your room using Python. G'day everyone, my name is Mr. Code and today we are going to continue coding Blast from the LEGO Mindstorms Robot Inventor using Python based on the Guard My Room activity from the Mindstorms app. And if you haven't already, then I highly recommend you check over here for my previous video on time to move. That way you can learn all the basics of assigning motors and programming motion for this Blast robot. Python is an extremely popular and useful coding language to learn. You don't need a lot of coding experience to get started, and it is a natural progression from graphical coding languages like Blockly or Scratch. And these videos are going to help you make the move from these block-based coding languages to a typing-based coding language so that you can work on more real-world applications like websites, video games, and apps. And just like the last time, we are going to open up Mindstorms to check out the activity in Scratch before doing the same thing in Python. So let's open up Mindstorms. Here we have Mindstorms. When you open it, you're going to see Blast in the middle. We click on that. And then make sure you followed step 1 all the way to 4 to build Blast. After you've built him, you go down to the bottom on further activities. And if you haven't downloaded these, there might be a download button on the side here. So today we're going to do Guard My Room. So you click on Guard My Room. You can skip the video. Oops, sorry. Oh, you gotta hit the start button. So here is the code in Scratch. As you can see, we have a block here that triggers when the program starts. It sets the button color to red. Then we set the orientation of the screen to left. And like I mentioned in the last video, what this does is it makes all the graphics, like the words that are written on the hub, it makes it rotated the correct way so that it is not flipped around. It creates a scanning animation and then it calibrates the robot. Calibrating the robot is where the robot is going to move its motors in a way so that it is in a very predictable position. Then we set the movement motors to C and A, and then we set the movement speed to 10%. And then we are moving motor D, which is actually the torso motor, 100% and spinning it around. And what this does is it lets you lift up the scanner for our robot. So Blast has a scanner in the form of its distance sensor. It's going to lift up its distance sensor to start scanning the room. And then it goes through into this forever loop. This forever loop is going to make a sound, the scanning sound, and then it's going to move around left and right 6 centimeters at a time. So it's going to be moving around 6 centimeters in this little arc to detect if there are any intruders. This second program block is using the same event. When program starts, it waits for a few seconds and then it starts to detect if something comes closer than 40 centimeters. Once something comes closer to 40 centimeters, then it stops other stacks, which means the other coding block up here, the other coding stack, gets stopped. So it stops moving around. And then it starts an animation to show a crosshair, plays a little bit of sound, and then it's going to lift its gun, and then it's going to shoot the target. Afterwards, the robot shuts itself down. All right, so pretty simple stuff. But there is something really, really important to note here. You'll notice that the code in Scratch is executing in parallel because there are events. Okay, so these are events when program starts, and the code inside each stack is operating at the same time. In Python, we can't actually do that. There are no event listeners in Python, which means that everything needs to occur line by line. The great news is that this is still 100% possible to achieve in Python with some inventive coding. So I spent a lot of time on making this solution. So if you haven't already, make sure that you like this video and give my channel a subscribe. It is your support that makes it possible for me to create more coding videos. So thank you in advance. Here's the plan. Instead of creating events and event listeners, we will treat this like a game loop, where one while loop is going to determine everything that the robot does, and we will blend both the scanning and the shooting codes into the one loop. Okay, so that is our plan. Let's go back into Mindstorms, and let's create our new program. So up the top here, I want to press the plus sign to create a new project. And then we choose Python. Hit create. So first thing is that we are going to create our object. So here's our hub. And then we're going to go torso motor equals motor D. So the torso motor controls both the head and the arm positions. Gun motor is going to equal motor B. So the gun motor is going to make the actual gun shoot. Wheels are equal to motor pair. And just like the last episode, we're going to go, the motor pair is C and A. Distance sensor is going to be equal to a distance sensor at F. And then we're going to create a Boolean value for if the robot has found a target, because we only want to repeat the action of seeking for a target until the target is found. So here we're going to call it target found, and we'll start it off as false. And then we're going to need to find a way to let us know if we're scanning towards the left or scanning towards the right. Because if we're scanning towards the right, we only want to keep scanning towards the right until we reach a certain angle, and then we scan to the left again. So we're going to create a Boolean to set that flag. So here we go, call it scan right equals true. So we start off scanning towards the right and then towards the left afterwards. Just going to make the text a little bit bigger. After we have created our objects, we're going to create our functions. One of the blocks that we saw in Scratch was the blast calibrate function. So here we're going to call it calibrate. And in order to calibrate the robot, basically what we're doing is we're moving the torso motor all the way to one side for a few seconds. That way it ensures that the motor is moved to its limit, and then it rotates the other side for a number of rotations. So here we go, torso motor dot run for seconds for 3 seconds at a speed of 50. And then we're going to go torso motor dot run for rotations to 2.3 rotations at a speed of -50. Okay, don't forget that we are rolling for rotations, seconds first, and then rotations afterwards. This is going to calibrate the robot. Our next function is going to be for raising our sensor. So we go def raise sensor. Torso motor dot run for rotations 1.5 at a speed of 50. Make sure that you keep an eye on these decimals, so don't mix up your decimals with your commas. Okay. And then our final function is to shoot the gun. Okay, so def shoot. We go torso motor dot run for rotations 2.3 and -50. And then we'll get our gun motor to actually shoot the gun. Run for seconds 0.475. Gun motor dot run for degrees -130 75. Then gun motor dot run for 14 degrees 60 75. So these movements are going to make the motor just wobble a little bit, just to hit both of those missiles, and then it's going to return to that center position. All right, here we are writing our program. So now we just delete the speaker hub beep. And what do we want to do when we run the program? We want to first of all calibrate our robot. So calibrate. So this is the function that we wrote to adjust the motors for the arm and the head position. And then we're going to go raise the sensor. And then we're going to turn the light to red to show some danger, right? So hub.statuslight.on. And then in brackets, in quotation marks, we put red. Hub.motion-sensor.reset your angle. What this does is it resets the built-in yaw angle of the gyroscope. So it turns it to 0 so that when we're moving around, then it doesn't change the reading. It starts off at 0 so that it's ready for us to start detecting our angle. Now here is the game loop that I'm talking about. We need to create a while loop that both incorporates the shooting code and the scanning code, and that is pretty tricky. It's not going to be really simple, but hopefully after you've seen the way I've coded it, then you'll understand the power of Python. So while target found is equal to false, that means that we are going to do this loop only until we find the target. So we're going to go set the distance. We're going to create a new object in here called distance, and it's equal to distance sensor dot get distance centimeters. And if distance is equal to none, distance, not distance sensor, equals 0. Why do we do this? This is to break a bug that happens on the Mindstorms distance sensor. Sometimes it gives back a none value, and if it's a none value, we can't compare that with any number. We can't see if it's more than or less than a certain number, right? If it's none, it's nothing, not even 0. So we can't have a none value. That's why we need these 3 lines of code to make sure that we handle it. If we receive none, it means that the distance is going to be 0. Okay? Some people set it to 0, some people set it to 200. Whatever it is, just keep that in mind so that if there is an error, this is the reading that you'll get. After we've checked to see our distance sensor is reading, we go if scan right equals true. Then I'm going to get my wheels to start moving towards the right. So the first argument in start is the steering value. So 100 means that we are turning on the spot towards the right. Negative 100 is towards the left. And then we put in our speed, which is 10%. Else, we do the opposite. Wheels.start, negative 100 at 10%. Then we outdent again to do another check. We need to see if we are scanning toward the right far enough. So we're using the gyroscope to see what angle it is that we are scanning. So I'm thinking maybe 30 degrees would be a good little arc for our robot to defend. So if the absolute value of the hub.motion sensor .get your angle is more than 30. All right, so this means that if the absolute value, so it doesn't matter if I'm scanning to the left 30 degrees or towards the right to negative 30 degrees, it's going to get just the amplitude of my movement. It's not going to care if it's a positive number or a negative number. It's just going to get the absolute value. Okay, so here we got if the absolute value of my sensor's yaw angle, which is the sideways motion, is more than 30 degrees. So I've scanned more than 30 degrees toward the right or more than 30 degrees towards the left. Then I'm going to flip the scanning right boolean. So here, if scan right equals true, scan right equals false. Remember that if we are testing something, we need to have two equal signs. If we are assigning a value, we need to have one equal sign. Okay? Else, scan right equals true. And then, of course, we also need to make sure we outdent to reset our yaw value, because we've just scanned all the way to the side, and then, yep, we need to now flip it, scan towards the other side. But before we do that, we're going to set our yaw angle back to 0. Otherwise, it will stay at 30, and it won't know that the angle is resetting. So here we go, hub.motion sensor .reset yaw angle. Okay. So if we test the robot now, you'll see that the robot is going to start a scanning motion. So let's test out our scanner. Going to test my robot, just turning it on. Going into Bluetooth. Connecting. Alright, it's connecting. So all I have to do is hit the play button, and then the robot should start scanning. Yep, so it's doing its calibration first. It raises its sensor, and then it starts scanning. Okay, so it's working perfectly fine. Now the next part is going to be for us to detect if a target has come to within 40 centimeters, and then it's going to lift its gun and shoot the intruder. So let's go back into our software. And then just behind me, down here, I'm going to have to stop the robot. Okay. And let's continue our code. So our final bit of code is to detect if there is an intruder within 40 centimeters. So if distance is more than 1 and distance is less than 40. Now, why do I have to check if it is more than 1? Well, remember that if we have an error, it is at 0, right? So you might get zeros all the time. So we don't want that to our robot to be shooting when it receives an error reading for its distance sensor, which is why we are going to detect if the distance is more than 1 centimeter and less than 40 centimeters away. And then for our robot to consider that to be the range for having an intruder. Okay, so here we'll, after we've detected something in range, we're going to do a few things. We're going to get our wheels to stop, and then we're going to run the shoot command, and then we're going to say target found equals true. And then just for fun, we're going to get the hub to write on its light matrix. Alright. Target destroyed. Okay. Alright, so now I'm going to load the robot and test it out. That's it from me today. I hope you enjoyed coding Blast using Python. You can download the program using the GitHub link in the video description. And if you like this content, make sure you give the video a like and subscribe for more. I'll see you next time. Bye bye.